Okay, so um, we left off saying he's standing on the high dive platform for several seconds. We want the first part to be flat because he's just standing there, he's not moving. So all of these are flat, all right? Based on the second sentence, he dives into the pool and swims around. So if he's diving into the pool, the second part should be going down because um, he's going toward the pool, not away from the pool. So this one going up, so that we're going to eliminate that choice. This one's okay. This one's okay because it's going down, and this one's not okay because it's going up. All right. And then we need to think about what this sentence is really saying. He dives into the pool and swims around. Well, he's at the platform, right? And the vertical axis represents the distance above the pool. So if he's diving into the pool, his distance above the pool is going to be what? It's going to be 0 when he's actually in the pool. So this has to be our answer, okay? Let's double check that with looking at the third sentence. He then climbs back up toward the high dive platform. So yeah, this, even though you can't see it with my pen there, it's an arrow going back up, so he's going back up toward the platform. Okay, second part of this question, part B, we have time on the horizontal axis and speed on the vertical axis. Okay, so Ivan is driving at a constant speed. So based on the first sentence, what are we looking for? What does constant speed look like? Well, his speed is not changing, so we're looking for something flat. Is this flat? No. Is this flat? No. This flat? Yes. This flat? No. So just by using some process of elimination, we can probably safely say that this is our answer, all right? But let's just double check it with the rest of the question. Okay, so speed is constant. He slows down, so the speed's going to decrease to pass an accident. All right, after passing it, he gets back to his original speed. So here he's slowing down, then he gets back up to where he was over here, and then continues driving at the speed. So yeah, the third answer choice does match up with that. Okay. Okay, I think it's time to have you pause the video and go try the 2 questions from number 4. Okay. So for number 4, we've got time and speed. David is driving on the freeway at a constant speed. So we need something that starts off constant, which means we can eliminate that. This one's okay. We can eliminate this, and this one's okay. So it's going to be between the second and the fourth choice. Okay. So let's look at the rest of the question. He then speeds up to pass a truck. So we need the second piece to go up. This piece is going up, and so is this piece. So we can't eliminate based on that. So his speed's constant. He has to speed up because he encountered a slow-moving truck. So after passing the truck, he exits the freeway and slows down. Okay? So what's going to happen to his speed? Well, if you're exiting, I sure hope you're going to slow down. So the speed has to be going down, which it is in the second choice. Over here, the speed, he's going even faster than he was going here. In fact, after he sped up to pass the truck, he maintained that speed. Okay, so your answer is going to be the second one for part A. Okay, for the last question, so we have time and then distance from the nest. And I'm going to tell you, this is the kind of question where people tend to make silly mistakes because, again, they're not reading what's on each axis. So a bird of prey leaves the nest to go hunting. So time, distance from the nest. Well, if he's leaving the nest, Is he getting further away or closer to the nest? So as he leaves the nest, he's getting further away from the nest, which means his distance from the nest is going to be increasing. So we want to look for a graph that starts off increasing. Well, this is increasing over here. This is increasing over here. This is not increasing, okay? So we can eliminate that one off the bat, and this one is increasing, okay? It flies for several miles away from the nest, okay, before stopping to eat. So flying away from the nest is what we talked about with the leaving the nest to go hunting, and then it's stopping to eat. So when it stops to eat, is it getting closer or further away from the nest? Well, it's stopping, it's not moving anywhere, so its distance from the nest is going to stay the same. So we want the second piece to be constant, right, to be flat. So this works, this works, this one we already eliminated, and this works, okay? So we can't eliminate anything more just yet. Okay, so after eating, after his distance stays the same, it continues flying away from the nest for several more miles looking for more food. So what's going to happen after we have that flat piece? Well, the distance from the nest is going to continue to increase. So is this continuing to increase? Yes. This continuing to increase? No, it's decreasing. This one already eliminated, and this one decreases, and then it increases again. It doesn't say that he got, the question would have to say that he flew back toward the nest. It says that he flew away from the nest, okay? So your answer to this one is going to be, A, or the first choice. Okay, so you should be ready to complete the assignment now.